All right, guys, we're going to look at estimating a correlation coefficient, in this case with an outlier. And so let's talk about that first. We're going to do the old rectangle technique for measuring this correlation coefficient, or estimating the correlation coefficient is probably a better way of putting it, because of course we can only approximate with the use of this little guy down here called a ruler. But before we do that, I want to pay attention to that dot right there. So this guy is known as an outlier. And he's an outlier because you can see that he doesn't really fit the pattern of the rest of the data. When we group the rest of this data into our nice clean rectangle, you're going to see he really stands out. And so we don't include him. Otherwise, our rectangle would get really wide, which I'll demonstrate for you in a second. So for now, for our purposes, we are always going to ignore any outlier that doesn't fit the data. You might ask yourself, how do you know? Like, what if it's here? What if it's here? What if it's here? Well, let me tell you, for the purpose of the exam, it will always be obvious. Like, you can really tell that this guy is really far away from the rest of the distribution. So our first step is always going to be, I always like to take a ruler and I'm going to try to line it up so that I cut that data pretty much right in half. Again, this is an estimation, right? We're approximating here. And I want to emphasize that word estimation. But you can see that this line roughly divides my data into two. It's not perfect, but it's pretty close. And you're going to have to try to be as accurate as you can. Next thing we're going to do is we're going to create our rectangle. Now, when we create the rectangle, it's really important, as accurately as possible, that we create those 90-degree lines that come across at a perpendicular. And one of the tricks, I don't know if you can pick this up in the camera shot here, but one of the tricks I do is I pick one of these long lines from the rulers. So if you see like that 20 right there, that nice long line, and right across from that's another series of long lines. They're inches. They're not perfectly lined up, but they'll help us when I kind of come down here. And you can see I'm following that line along the other line, so I know I'm good. Now look, I don't want to be way out here when I make my next line. It's going to make my rectangle too long. I want it to just touch the outside of that dot. And you can see it's just touching the outside of that dot now, and I have a nice clean 90-degree angle there and a nice clean estimated 90-degree angle there. So these are going to be the ends of my rectangle. Next thing I'm going to do, I'm going to come out and I'm going to start sliding this ruler up. Again, I'm going to try to line it up on the nice big numbers, and until I touch that outside dot, and you can see that that's the outside dot in this instance, come right down there and draw your line. You can see that. And then coming over to here, same thing, use the lines of the ruler to help you, and try to be as neat as you can, and I'll talk to you about how much error you can have afterwards. So right there is my ruler, which my rectangle, which I'm going to use to estimate my correlation coefficient. Just to clean that up for you a little bit, you can see right there. And you don't have to do this when you're doing it for your test, but see it right there. And you can see the nice clean lines. And that box really kind of stands out nicely now. So the next step is take our measurements, because we're going to need to apply the formula that we'll remember. That's the small side, and that's the big side over there. And we have a formula that says R, which is the correlation coefficient. Why they don't pick a C is beyond me, but there you go. That's mathematicians for you. Is equal to, plus or minus, we'll talk about that after, 1 minus, and then it's going to be small over big. And so I need the small number and I need the big number in order to simplify that decimal, and then we'll talk about direction afterwards. So again, very important that when you do your measurements, you do them as accurately as possible. And I'll talk about your range of error afterwards. So when I did this, I got exactly 1.9 on my width there. And I'll tell you another little trick if you're interested, is sometimes in case one side of your rectangle is a little longer than the other, usually you can average that error out by measuring through the middle. Mine came out exactly to 1.9 again. I drew that pretty good. So small is equal to 1.9 centimeters over there. And the big, I'll measure through the middle, came out to 10.123. So the big is equal to 10.3 centimeters. Now, again, I'm going to ask this estimation of the correlation coefficient using this measuring technique. You know, you can see already how if your rectangle's a little bit off, or if when you're looking at your millimeters you miscount a little bit, it can throw off your calculation, and I'll show you by how much you're allowed, because there is a margin of error. So let's do this over here first. We're going to go R, maybe I'll come up here so we can see it a little better. So we're going to go R is equal to, now this plus or minus, I'm going to leave them there for now. Open that bracket up, and I'm going to go 1 minus, now the small was 1.9, and the big was 10.3. And then I'm going to close that bracket off. So the calculator time, really important now. We have to simplify the calculations inside this bracket. And order of operation says, right, we're going to take care of this division here first, then we'll do the subtraction. And I don't want you to touch this. This part of the formula here, we're always going to deal with last, okay? And this is going to come from your own brain. And actually, it's going to come really from your own eyeballs, because we're going to look at that graph afterwards, and we'll see how that works. So, R is equal to, we'll leave that plus or minus alone. We're going to go 1 minus here, and now we're going to simplify that fraction. So 1.9 divided by 10.3. And when we do that, we get 0.18446, blah, 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 blah. We're always going to round to 2 decimal places. So I want that 0.18, and then I look over at that next number. Now that's a 4. So I'm going to leave that at 0.18. Had this been a 5 over here, this would have rounded to 0.19. But it doesn't. It stays at 0.18. And now I'm going to take that away from the number 1. So I'll just clear up my calculator there. And I write down R is equal to, still hanging on with that plus or minus for now, and I'm going to go 1 minus the 0.18 or 0.18. And when I do that, I get 0.82 or 0.82. So there's the strength of my correlation coefficient. It's pretty strong. It's pretty close to the number 1, and you can see that that pattern was fairly linear. But the question of positivity or negativity that we have to deal with, I want to remind you that you've got to eyeball that. And you're going to make this decision. This has no mathematics here. This is purely based on your knowledge of one important fact. And the question is really the following. Is it a positive or is it a negative? And remember that that question right there is a question about the slope. And it's a question about the slope of that line that runs through the middle of the data. And we've already learned in our way back in y equals ax plus b that negative slopes are always going downwards. That's the negative slope. A positive slope would be something that looks like my pen right now, right? So something that's going up is a positive slope, whereas this one is falling down. That's a negative slope. And so because we have a negatively sloping line here, we can now say at the very end, or the last statement, that our R, our correlation coefficient, is equal to negative 0.82. Now, last thing to say, you're allowed a margin of error. So on the exam, I have to accept any answer that runs from 0.05 below that. So not that you need to know this, but 0.82 minus 0.05. I want to make sure I don't make any calculation errors there. So you're allowed to have any answer from negative 0.77 all the way up to negative 0.87. So plus or minus 0.05. So you can be 0.05 off to the good or to the bad. That gives you a nice wide range. So if you're careful about how you make that rectangle as much as possible and touch the outsides of the dots and measure carefully, then the calculations, if you follow your algebra properly, should easily land you within the pocket of the perfect answer, right? So if mine is the perfect answer, you're allowed to be 0.05 below it or 0.05 above it. And if you do that, those are 4 easy points on a final exam.